Hi, I'm not going to do the picture-in-picture for this one. It's most important for you to see the screen with the thing. All right, so we're on number 5 now. All right, so a sample of final exam scores is normally distributed with a mean equal to 20 and a variance equal to 25. So now we're moving into the next phase where we were in class, where we set up our graphic so that the top is 0, 1, 2, 3, negative 1, negative 2, and 3. But now we're going to put below that the raw score values. Okay, so you can even say like raw and Z, okay, to label it. So you keep it straight. So then it says that the final exam has a mean of 20, but it said it had a variance of 25. So we need to get the standard deviation, and that's the square root. And so then I have the 5. So that's where I got the mean is 20, 25, 30, 35, 15, 10, and 5. All right, so I've done this for each of the 4 questions. I think it is A, B, C, D. All right, so the first one, A, says what percentage of scores is between 15 and 25? Okay, well, this is pretty easy for us. We've done it before. So that's between -1 and +1. So, right? And we remember that that was 34. So -1. All right, so 1, again, here, is 0.34134. So 34.13%. Okay, so 34.13 over here, 34.13. Put together, the answer 34.13 plus 34.13, you get 68.26. Okay, so that's A. Then B says, what raw score is the cutoff for the top 10% of scores? All right, now this one's a little bit different. So now what we have to do on this is we have to figure out the top 10% of scores. So we're going to find the percentage. Okay, and then of the area beyond Z, because it says top 10%. Okay, so it's going to be top 10%. Okay, so that it's the area beyond Z. So we want to go for a 10% value. The area beyond Z over here, I've got 10.5, 10.3, 10.2, 10.00, and then we're to 9.8. So let's go here. 10.027. All right, so the Z value of 10.03%, all right, 10.03%, oops, sorry, is 1.28, okay? So this Z here is 1.28. So we have the Z value, but what we really need is to get it back to into a raw score. Okay. So in this one, okay, we're going to go from a Z score to a raw score. So to get the raw score, our formula is X, okay, equals Z times the standard deviation plus the mean. All right, so Z is 1.28 times our standard deviation is 5 plus our mean is 20. Okay, so our value here, our X equals 1.28 times 5, okay, plus 20. So it's 26.4 right there. So 26.40. And the question says, B is what raw score is the cutoff for the top 10% of scores? So the cutoff is 26.40. Okay. Now C comes along and says, what is the proportion below 13? Okay, so for this one, if you look here, up at C, it's 13, so 10, right? 13 puts us over in the negative, right? Because the mean is 20. So you see, it's going to be somewhere around here, all right? So we have our X, we need to get a Z. So the Z equals, because before I just figured it out that, you know, the 15 and 25 was 1. But for this one, we actually have to do the math. Okay. And so proportion below 13, we're looking at this. So what proportion of kids scored below 13 or whatever it is. And so then we have Z equals 13, X minus the mean, 13 minus 20 divided by the standard deviation. Okay, so 13 minus 20 is negative 7, okay, divided by 5. So it's 1.4 negative. But remember, the graphic is just, so the negative tells us that it's going to be the area beyond Z going that way. And this, with a Z of 1.4, a Z of 1.40, and we're looking for the area beyond Z because it said everyone below 13. So it is 1.4, and so it is 0.08076, so 0.0808. Okay, so 8.08%. Okay. Z of 1.4 has percentage beyond of, you can say 0.08076, so 8.08%. That's your answer to that one. Okay. All right. And then the last one of D is what is the probability, which is the same as a proportion really. What's the probability of a score less than 27? Okay. So this one's a little bit harder because we've got to do two things. We've got to go less than 27. So we're going to have to find what Z value this is. And then we're going to have to add 50% to it. Okay, because that's all of this. Okay, so 27. Okay, so to get our Z of a 27, Z equals, okay, 27 minus 20 divided by 5, 7 divided by 5, okay, is again 1.4. Now, on this, so we found that last time just to make it easy, right, of the 1.4. But this time, we have to go the area between the mean and Z, okay, not beyond. So this is why shading helps you know what you're looking for. So we're looking for this percentage here and then adding 50 to it. All right, so 1.4, area between the mean and Z this time, is going to be 0.41924, so 41.92%. Okay, so 41.92% for this area here. Okay, then, so 41.92 plus 50 is 91.92% is the answer to number 5D.